Hello everyone, I'm Jeroen Vermeij and welcome to my lecture series on computer and network security. In this sixth lecture, I will talk about authentication and access control. In the first video, I will explain to you the difference between authentication and authorization. Authentication and authorization are actually two very important concepts in system and network security. And although their names may sound similar, they actually have quite different meanings. First, let's take a look at authentication. Authentication will verify the identity of a system entity such as a user. Authorization, on the other hand, will verify the entity's rights to perform specific actions. As such, a system will generally first authenticate the user to make sure the user is who he claims he is, and then, based on their verified identity, the system or network will decide what kind of actions the user can perform. Combining authentication and authorization is referred to as access control. Also note that in this context, authentication refers to user authentication and not to message authentication, which we talked about in previous lectures. Message authentication instead refers to verifying that the contents of a message has not been altered while being transmitted from a sender to a receiver. This figure shows in more detail how user authentication works. This figure is based on the NIST SP 863-2 standard, and it provides an authentication architectural model. So in this model, there are basically two steps, where first the subscriber has to register, and second, he can use the information of the registration to authenticate himself. So in the first step, the subscriber will prove its identity to a registration authority. This proof can be provided in the form of an email address or an electronic ID, and so on. Second, the registration authority will interface with the credential service provider, RA, to confirm the registration. Based on the proof of identity, the credential service provider will then provide the subscriber with some credentials or a token. This could, for example, be a password or an encryption key. The subscriber can then use this information to gain authenticated access to some system or network. Using an authenticated protocol exchange, the subscriber, in this case also called the claimant, can contact the verifier to prove its identity based on its identity information, such as an email address, and the token, such as, for example, a password. The verifier will ensure that this information is correct with the credential service provider, and if it is, it will authenticate the user and relay this information to the relying party, which is basically the system that the user is trying to gain access to. If everything is correct, the claimant can then set up an authenticated session with the relying party. An authentication of users in modern computer systems and networks is usually based on one of three methods. It is based on something the user knows, has, or is. Something the user knows could, for example, be a password, a PIN code, or the answer to a security question. Something the user has could be a cryptographic key, an electronic key card, or a token generator, like, for example, Google Authenticator. Something the user is could be their fingerprint, their iris, or any other biometric information. All of these methods can be used for authentication, but all of them have their advantages and disadvantages. For example, a password could be guessed by an attacker, or the user could forget it. Information the user has, like a cryptographic key or a key card or a token generator, could be stolen, and biometrics have their own problems, such as, for example, problems with false positives and false negatives. On top of that, multiple of these factors could be combined. So by combining multiple methods for authentication, we can improve security. This is referred to as multi-factor authentication. A specific case of that, two-factor authentication, is these days often employed on modern computer systems. Access control services manage access to a computer system or network. Such an access control service will provide several functionalities. First of all, it will provide authentication of the user by verifying their identity and allowing them to log into the system. Second, it will perform authorization, determining what data logged-in users can access. Also, what actions they can perform, which resources, for example, of the system or network they can access, such as data, processes, software, hardware, and so on. Moreover, a fourth task it performs is to examine the health of the user's computer, mobile devices, and the internal system resources. And specifically for access to computer networks, several enforcement methods exist to ensure only authenticated and authorized users receive access to these network resources. For example, IEEE 802.1x is a link layer protocol that enforces authorization before ports are assigned to IP addresses. This standard makes use of the Extensible Authentication Protocol, or EAP, for the authentication process itself. Firewalls are software or hardware components that allow or deny network traffic between internal and external hosts on a network. Virtual local area networks are an approach in enterprise networking consisting of an interconnected set of local area networks, or LANs, where they are logically segmented into a number of virtual local area networks. Finally, DHCP management is based on the Dynamic Host Configuration Protocol, or DHCP, which is an internet protocol that enables dynamic allocation of IP addresses to hosts. In DHCP management, a DHCP server intercepts the requests and assigns IP addresses instead. Thus, network access control enforcement occurs at the IP layer based on subnets and IP assignments. On top of these network access control enforcement methods, there are also related supporting technologies. For example, intrusion detection monitors a network or system for malicious activity or violations of security policies. If such violations or malicious activity is detected, a network administrator is notified. Second, IP layer security, or IPsec, allows authentication and encryption of data flows between hosts and networks and is an enabling technology for virtual private networks and VLANs. In the next videos, I will go into more detail in several of these technologies, like IEEE 802.1x, firewalls, intrusion detection, and IPsec.